Alright, this is continuation of Chapter 3, Section 1, solving system of equations by graphing. So what I'd like you to do is we're going to look at this graph right here. Alright? And we are going to solve for the slope and the y-intercept using the traditional method of solving for slope and y-intercept. Because right now this is not in y equals mx plus b form. This is in standard form. So right here, this is in standard form, which means if I have x plus 2y equals 4, and I wanted to change this to y equals mx plus b, you could simply solve for y. So if we wanted to solve for y, the first thing you're going to do is you got to isolate the y variable. So what do we got to do to get rid of this x over here? Subtract them from both sides, right? So I'm going to subtract an x from this side, and I'm going to subtract an x from this side. And we have 2y equals negative x plus 4. So all I have to do is just move that negative x up front. And then what? Divide everything by a 2. Now sometimes students get stuck because this is what they see. They see a negative x over a 2, and they're like, 4 divided by 2 is 2. But they're like, wait a second, what's the... It's a negative half, because that's actually what? A negative 1x over a 2. So I'd like you guys to write your equation as negative 1/2 of x plus 2, which gives us our slope, and it gives us our y-intercept. Our slope is negative 1 over 2, and our y-intercept is at a 2, which means we have to go down 1 unit and over 2 units every single time. That's our constant rate of change. And would you guys agree the y-intercept at a 2 is a very easy point to plot? Right up here at a 2. And then from this point we go what? Down 1 over 2 units, put a point. Down 1 over 2 units, put another point. You guys can see the pattern there. Just extend the pattern. You can also go up 1 unit, but over 2 units to the left. Continue that pattern. And draw a nice straight line, just like that. That's a very traditional way by doing what? What did we solve for? We solved for y. And we changed everything to this form called slope-intercept form. And they call it slope-intercept form because it gives you your slope, and it gives you your y-intercept. In a form. They don't call it boogly-boogly form. They call it slope-intercept form for a reason. Now, that was a very traditional way. Now we're going to do a non-traditional way, because we like to do things sometimes non-traditional, because we're fun. Yeah. This is a very non-traditional way of having fun. If you're watching this video, either you really struggle at math, or you're just like, you know what, I want to review math. Or you're just really, really extremely bored and have nothing better to do. Alright? Good, somebody laughed. Look at that. Somebody laughed right there. Good, good. So right here, ax plus by equals c. Now, if you're going to do this method, you have to be able to identify what a is, what b is, and what c is. What is our value for a? 2. For b? And c? 1. Now, if this is in standard form, slope, your m value, will always be the negative version of a divided by b. Let's think about it. I've got a negative sign, right? What's my a value? 2. My b value is a negative 3. Negative 2 divided by negative 3. So guess what this is? This is equal to our slope. A lot of students get stuck in this whole process of solving in equations. So I'm trying to give you another way of being able to find what? Find your slope and your y-intercept without having to solve along equations. lowercase b, everybody, which refers to the y-intercept, is your c value divided by your b value. Capital C divided by capital B. So we have c is a 1, b is a -3. So right there, look what our y-intercept is at, a what? -1/3. And our slope is at a 2/3. So how do we write this in slope-intercept form? Y equals 2 over 3x minus 1/3. This is how you write your equation in slope-intercept form. We're still doing what? Y equals mx plus b. We just found a different way of solving for m and a different way of solving for lowercase b. So right now, we have found the slope and the y-intercept, so we're going to go to the graphing calculator. So turn your graphing calculator on. I'm going to turn mine on because I have an awesome graphing calculator. Thank you, Mr. Lapp. You turn it on? There it is. Mine's loading up. And I am going to go to y equals. There we go. Y equals. I'm going to clear this out. And what is the slope I need to type in? What was the slope? 2 divided by 3. I think I was already up there. I erased it. That's okay. So you can see the keystrokes. Minus 1 divided by 3. So there's my equation of my line. If you don't agree with me, let me show you. There it is. We go back. Scroll down. There it is. Going forward. There it is. All right. Now check your table, everybody. Check your table. Second graph. And I want you to look at your table and look at it carefully. I only want you to plot points that you can actually graph. Can you see the points you can actually plot accurately? -4, -3. You can plot that. -1, -1. You can plot that. So what I want you to do right now, you see these points on your graphing calculator? Tell me those points, and I'm going to make a table right here. Give me one point that you saw on that table. -1, -1, -1. Okay, I'm going to plot that point. What's the other one? 2, 1. You know what? That's enough. I'm going to take 2 points. So Ariel, I'm going to go -1, -1, and I'm going to plot a point. Then I'm going to go over 2 units and up 1 unit, and I'm going to plot a point. Now, if you think about this, it makes sense. What is my slope right here? It's what? 2/3. Watch. Up 2, over 1, 2, 3. It works. Watch this. 1, 2, over 1, 2, 3. Put another point. And guess what I've created? I've created my line. So there's my line. It has been created. Once again, I want you to follow the pattern of the slope. Maybe you never understood slope, and I'm sorry if that happens to be your case. But check this out. Right here, I go up 2 units and over 3 units. Up 2 units and over 3 units. And you should be able to see the stairs that are created, called the rise over the run. How much it goes up and down over how much it goes left to right. And hopefully you can see the slope is 2, 3. There's your rise. There's your run. And remember, your slope, your m value, is always the rise over the run. 2/3. It goes up 2, over 3. I know I'm sounding a little bit redundant for some of you who are watching this right now. Now that's not my final answer, but guess what? Where the 2 lines what? Cross. Where the 2 lines cross, what do we call that? We call that our solution. And what is the ordered pair for our solution? 2, 1 is correct. That's our answer. You graph where the 2 lines cross, you've labeled it 2, 1, and you're done. Next one we're going to do a little bit faster. All right, on to problem number 3. We have about 5 minutes left on the video. So right here, I'm going to highlight the 2 problems. This one I'm going to put in blue. And this one I'm going to put in red. Now, one of them is ridiculously easy to graph because one of them is in slope-intercept form already. Which one's already in slope-intercept form? Or you could say the red one. b equals -9/2. All right? So right now, I want you guys to hit the y equals button. All right, hit the y equals button. Type in 1 divided by 2x minus 9/2. Let's do it. Okay, hold on. Clear this out. I'm going to do 1 divided by 2x minus 9 divided by 2. And then hit the second button and the graph button, and let's look for some points we can actually plot. We can do that. -5, -7. What else? What's an easy point?
-3, -6.
Okay, those are easy. That's easy. That's easy. 1, -4 is easy. 3, -3 is easy. We just plot those ordered pairs. All right, we go back here, and Donovan, give me one ordered pair that I can totally plot on this red line. -1, -5. We go down here. -1, -1, 2, 3, 4, 5, right here. What's another point I can do? 1, -4. That's good. Perfect. Now check this out. We can actually see from these 2 points, you see the up 1 and over 2. So now I can go up 1, over 2. Up 1, over 2. Good point. Follow the pattern. Follow the pattern. Rise over run. Now I'm going to connect them. Right now with a nice solid line. Connecting those points. And I'm done. I am done with the red line. Everything is plotted and everything is drawn out. The last thing I'm going to do is I'm going to look at this 2x plus a y equals 3. And I want to graph that. Would you guys agree? Anytime you see y by itself, that's good. That's really close to what? It's really close to y equals mx plus b. There's only one thing I got to do. I got to take this guy and say, go across. So how do I get rid of a 2x? So I can subtract 2x from both sides, but if you know me, Jake, what do I like to do? I just like to throw it across. We get y equals -2x plus 3, because when anything ever goes across the equal sign, it just becomes the opposite of what it is. So if it was a 2x, it's now a -2x. All right, saves a little bit of time and energy. Now, m. By the way, we have a limited supply of time on this earth. I'd like to use it wisely. All right? So right here, we have -2x, so my slope is -2. What's my y-intercept? +3. So right here, I'm going to plot right here, 0, 3. That's a very easy y-intercept to plot. Why did we not do that last time? Because -4.5 sometimes it's tricky for some students to be able to plot -4.5. That's -9/2. What's my slope though? -2, which means -2 over a 1. Should I go down 2 over 1? Ready? Down 2 over 1. Down 2 over 1. Down 2 over 1. I love it when these points just cross nice and perfectly. Makes it nice, easy. There's my slope. It's going down 2 units over 1. And you guys should be able to easily see your what? Their solution right there. The solution, 3, comma, -3. 3, -3. There's my x. There's my y. There's my solution. Graph the 2 lines. See where they cross. Write the ordered pair. That's your answer. Good luck with it.